Okay, so now we talk about composite materials. Composites, so as the name itself suggests that there is something that there are more than one things, right? It's a composite, it's a combination of a couple of things. Now you will say that alloys are also combinations, right? You have some metal A, metal B, and then you mix them together, and what you get? You get an alloy. That's correct. So what is the difference between alloy and composite? Well, what happens in the case of composite materials or composite structures rather? Here we have two or more materials, but typically two materials that have different physical and chemical phases. What is a phase? Solid, liquid, gas. That's a phase, right? Yes, that also is valid here. Sometimes you can even mix two solids, but still one should be softer than the other. These two phases, what we call physically, chemically distinct phases, it's more like two different structures you have altogether mixed into one. You will understand it better if you read the second line. The first phase is the matrix phase, and the second is called reinforcement. How are they defined? Matrix is something like a soft polymeric material, for example, and say it is melted or it is in the liquid form when you're using it, and now I add some fibers into it or a cloth into it, something like that, and now I put them all together. Now my cloth or the fiber structure that I have added, that is called the reinforcement, and the soft phase is called the matrix. So now these are two completely separable things, right? These are not in the nanoscale, but actually in the large scale, you can visibly see the two completely different materials into one material. And also you are potentially able to separate them out also. So these kind of materials are known as composite materials. What is the need for making such materials? Well, most importantly, to increase the mechanical strength of structures while still maintaining low or lower density and weight. Okay, so lightweight. Here, one thing I should tell you, polymers are usually lightweight, right? Plastic things are lighter, and even wood, which is a natural polymer, these things are lighter than metals, that we know. So in terms of lightweight, we need more polymer-like structures. But in terms of flexibility, ductility, malleability, and also various other properties, we require even electrical conductivity. There we require metals. Now, can we make a combination of these two things? Something that is also mechanically strong, and it is also flexible, it is also lightweight. Because of course, think about something which is very strong and still lightweight. You can make airplanes much lighter, you can make your automobile much lighter, cars much lighter, and so on, but the strength you're not compromising. So that is why this whole thing, the entire field of composite material developed. Okay, now this is something you will understand with this example. Again, what is a composite material? If you want to make your own composite material, here is the method. You take a piece of cloth, okay, now you soak it into glue, whatever glue you find at home, okay. Now you place another layer of this cloth and then more glue, then another layer, then more glue. Do this 4 or 5 times and do it in anything, let's say a bowl or any plate or anything, any structure of your choice. And once the glue becomes hard, it will dry up and become hard after some time, then you can remove it from your bowl, or that is your mold, and now what you have is a composite structure. That's all. It's as simple as that. So here is my bowl, okay, and this is the cloth. The black one is cloth here, and the orange one is glue. So this is what I did. I did in a bowl, I put a cloth and then glue, and then I did this like 5-6 times, and after that I got rid of the mold, and what I now have is a structure made of composite material. So this is how composite materials are typically prepared. Okay, so they are basic. You can say that these are not materials, they are structures, because these are fibers. Or cloth, for example, itself has some structure into it. If you look at a cloth in the microscope, you will see the weaving patterns. In fact, if you take one thread of your cloth and see it inside the microscope, you will see thousands of tiny little threads inside it also. So cloth itself is a material. So how can you call this material? It's a combination of materials. Well, this is something that we can definitely argue. Are these materials or are these structures? Typically, composite materials industrially are called materials because we can give them various shapes, right? So if I have done this in a bowl, or instead of bowl I have taken a mug, or I have taken some very complex structure, all of them can be, we can make composite structures using different shape we can give. So that is why they are called materials, but you can also call them structures. This is the very definition. Okay, so this is something you can do at home. Now, important part is here, cloth is your reinforcement and glue is your matrix. Okay, fine. So now, in the case of industrial manufacturing or more advanced applications, you can have very complex composite materials, very complex composite structures. So for example, these fibers, now I gave you the example of simple cloth, but you can make these fibers also out of not just say cotton or silk, but very complicated or very new type of material. The material itself for making those threads has been designed, for example. So you can make carbon fiber. You can make glass fiber. Yes, you can make fibers out of glass. If you melt the glass and you let it fall, then you will see that you will get very thin structures, and these are like these structures are fibers. And you can also do winding with them and you weaving with them, and so you can make the cloth out of glass. So these are also some examples of various different polymers also can be used for making the fibers that are then used for making these cloth-like structures. Okay, now one more question is, do they have to be these cloth-like structures or fabric-like structures? Not necessarily, not always. Sometimes some other types of composite materials also just have some nanomaterial mixed inside a polymer. So nanotubes or nanoscale, whatever, nanofibers. So they can also be those kind of materials where you just have one additive or one reinforcement into a polymer matrix. By the way, this matrix doesn't have to be polymer. It can also be a melted metal. It can also be a ceramic. It can even be concrete. So you can have this matrix material and you can add something into it, and there you will directly mold it. Those materials are also known as composites, but the more common composite materials are these types where you have these fabric-like structures. So the most common ones are fabric-like structures, and the composites. They are called laminates, by the way, not important for the time being. Okay, so yeah, when we want to make some very fancy applications, when we want to, for example, make airplane body parts using it, then of course we need to also have full control on the property, or the weaving of our cloth itself should not have defects. It should have also very lightweight and good strength, and so on. So these are advanced composite materials. Here I have written that matrix material, which in most cases is polymer, can also be things other than polymer. Okay, but it has to be relatively softer in this uniform phase. You can imagine the name matrix itself suggests that it will contain something into it. Okay, now so you can also add nanomaterials or other kinds of materials inside. Okay, now what do these things do? The main reason why we are, at least in today's technology, making composite materials is to improve the mechanical strength of various structures. We can also increase or improve electrical conductivity, but for all these things, electrical conductivity, thermal conductivity, we already have metals and ceramics and other materials. But mechanical strength is where we can still do a lot of work, and mechanical strength is very important for a lot of applications because of the fact that a lot of technology depends on materials that can withstand more load, where also a lot of technology, a lot of fuel can be saved if we have lightweight aircrafts, lightweight automobile, and so on. So technology wants to go into this greener direction, right? So for that we need materials that require less load for being pushed, right, or for being moved, and their lightweight and strong materials are important. So most important application of composite materials is the mechanical applications, where they have better improved mechanical strength, and that is also the reason why we have these fabric-like structures that are more common compared to other types of composites. But other types of composites are also used for various applications we'll see. Okay, So yeah, this again, I have discussed this already. The composites can be placed somewhere between a material and a structure. So that is for you to decide. Okay. So coming to the applications of composite materials, so we already, now you must have guessed a few applications. Automobile, aircraft, I already told you. Anything that requires good mechanical strength and lightweight. What else you can think of? Spacecraft, wind turbine blade, that is a very interesting application. So we nowadays, the entire world is moving towards wind-based energy systems, and you must have seen windmills or wind turbines. Windmills, basically, in the past they were used for milling purposes. That is why the term windmill is still used. But nowadays, for generation of electricity, we call them wind turbines. So anyway, what do you need in a wind turbine blade? So you must have seen these big white color blades if you've seen a wind turbine. If not, you can do a quick internet search. So these blades need to be light, right? As light as possible so that they can rotate easily because of the wind. They should also have a specific shape. That is okay. But lightweight and strong, these two properties they should definitely have. So 99% wind turbine blades nowadays are made of composite materials. Okay, traditionally they were made of wood or even some light metals, but composite materials work much better because wind turbine blades also need to withstand very extreme weather conditions, so they should be mechanically strong, but at the same time they should be lightweight. So this is one example. There are also a lot of sports gear. When I go for hiking, I require tent, for example. Now, when you walk up a mountain, then even 100 grams extra weight can be too much. So you want to keep on reducing the size, the weight of these sports gear, but at the same time, you don't want to compromise on the strength. So there also a lot of composite materials are used. You can also look for some other applications. Yeah, so this picture I drew just to show you that it's not easy to break a composite material. Even the one that you make at your home, the one where you're going to use glue and cloth, try breaking it or tearing it apart. Even cutting it with scissors is going to be difficult. Okay, so breaking composite material, because of the fact that they have multiple layers and these are woven layers, they are like cloth-like structures. Already cloth, you can see, even if you take a single layer, it's not easy to just break it apart, right? And if you have multiple layers and then you have some glue inside them, altogether these are very strong materials, and that is why they are very useful for many applications. Also, they have some flexibility also, so you can bend them without breaking them, which is also a very important property. They can withstand a lot of impact, right? Okay, so yeah, composites, these are the laminate type composites, the layered composites, and the other ones where I was saying that you can add something, say a nanomaterial inside a lot of polymer. There you can directly provide a shape. There you can just do molding. So you pour it inside whatever mold, whatever shape you needed, you just pour it inside that thing. Let's say this time you cut down the cloth that you had into very tiny pieces. Okay, nanoscale. Not nanoscale, but say very small pieces. And then you mix that powder of your cloth into a bowl of glue. Now what you can do is you can take this entire bowl and then pour that mixture into something, whatever mold you require, and harden it, and then your shape is prepared that way. So that shape will be, of course, different from this kind of layered structure. You can make, for example, tooth implant can be made out of composite material. So you take the shape of the tooth into a mold. So you prepare a mold which is the opposite of the tooth shape. So it has the cavity that is of the shape of the tooth, and then you fill your polymer or your composite material into that, harden it. So that is the method of making structures using these type of composites, where you have nanomaterial or any small scale material mixed inside, powder type of material mixed inside a matrix. Okay, now composites are replacing metals. One example is this aircraft application, right? So they are replacing metals, but they have advantages, disadvantages both. One big disadvantage, which will in fact be a very interesting research or technological problem of the near future, is the recycling of the composite materials. Because see, metals, the biggest advantage is that you can melt them again, easily separate them, and easily remove them from, you can make some, reuse them. recycle, reuse, everything is possible. But in the case of composite materials, now you can imagine you have the how to you separate the cloth and glue afterwards, right? Or if there is some damage for any reason, then how do you dispose it? How do you recycle it? And also the fact that they contain polymers, and polymers are already difficult to disintegrate or dispose naturally. Recycling is a big issue with composite materials. Okay, but yeah, we are, everybody's working towards recycling, and we are also going to hopefully find some solution soon. What else? I told you that the matrix materials can be of different types. Even concrete can be, so you've seen concrete, if you've seen any building construction, you've seen the gray concrete, right? So concrete, cement, plaster of Paris, these kind of structures or materials also can serve as a matrix, and you can again add the cloth-like structure. Now imagine how strong you will, the structure will become so strong. Of course, you can use these kind of structures then for building bridges, for building a lot of things which require mechanical strength and lightweight. Right, so many civil engineering applications nowadays are also using composite materials. Okay, now here also we have the flexibility. The fact that we are making the materials ourselves tells us that we can induce certain properties also. For example, as I said, that we use carbon fiber, for example. Carbon is electrically conductive, so you get electrical conductivity now in your entire composite structure. Similarly, thermal conductivity and other properties can also be incorporated because we are synthetically making these things. Okay, their manufacturing, actually I don't know if I should call it simple or complex, because making these layered structure, that part is simple relatively. But before that you have to also make the fabric or whatever nanomaterial, whatever you're adding, and also the matrix material, and also the combination of these two things may not always be easy, because you need to also make sure that they are mixing very well. They are there is no gap, air gap between them, and so on. So in that sense, altogether, if you see the overall preparation of a composite material, because it goes in multiple steps, then it can get a little bit more complex. But anyway, if for this particular course you don't need to anyway go into further details. One thing you should also remember is, when we machine these things, machine means the things that you will be doing in the workshop, cutting, milling, polishing, giving, edge milling and things like that. That is also a little bit complex in the case of composite materials. Why? Because the two components of the material, glue and cloth, for example, will have different properties, different thermal conductivity, and different electrical conductivity. So the same tool cannot be used for both of them, and so on. But for now, I think this introduction to composite should suffice.